I can make one up if you want to.
Yeah, let's just do that.
Okay, so let's do and we have 30 grams of this, and we're looking for atoms of phosphorus.
Mm-hmm.
Okay.
All right,
So we're starting with this.
30. I'll just do it right here.
That's fine.
So if I have 30 grams of H2PO4 and I want phosphorus, then I would say that I'm going to get rid of my grams. So I would grams of H2PO4. I could say that there are, I could take the molecular mass of this and turn that into, I could say 1 mole will give me whatever the molecular mass of that is, right?
Right, so let's add that together so we can go through all the numbers. So hydrogen is 1, right?
Yeah.
Oxygen is 16.
And do you, like, when you're doing calculations like this, can you just kind of do, like, I know it's 1.008, and I know that oxygen is 15.999, but you could just say there's just 1. So
It just depends on how precise
accurate
your measurement is. So we only have 1 sig fig here. So really we could do 1, and because oxygen is 16, we could even put that up to 20. Does that make sense?
Because oxygen
That's 16, and if we rounded it to 1 sig fig, it'd be 20. Because oxygen's molecular weight is 16.
Mm-hmm.
To make this 1 sig fig, we would turn it into 20.
Oh, okay, so you're saying.
Mm-hmm. But then that would throw our numbers off, right? That would just be doing a really rough approximation. And so for these problems, you want to do at least as many sig figs that are in the question. I would recommend doing 16, so just rounding off to a whole number instead of a decimal.
Okay, so I've got 2 hydrogens and 1 phosphorus. I don't know how much phosphorus weighs.
Let's see, phosphorus is just 31.
So that's 33, and then 4 oxygens. 4 times 16 is 64.
So it'd be 97 total.
97
Mm-hmm.
grams, and then I've got rid of my grams, and then I could go to, now I gotta get my moles, and I would say that there is, and I want to find phosphorus, so there is 1 mole of phosphorus for every 1, how would I say that, 1 molecule of,
Yeah, just 1 mole. Yeah,
so I would
it's
just
the
say
same.
1.
So whatever these units are, you keep them the same so they can cancel each other out, because this is just a ratio that we're looking for.
Right.
And so it's the stoichiometric ratio. It's just the numbers that it's talking about.
So I would just say that there's 1 mole of phosphorus for every 1 mole of H2PO4.
Right. Or you could even say 1 atom per 1 molecule, whatever you'd like to, however you want to define it.
H2PO4. And so I would have written 1 mole of H2PO4.
Right.
And then and that's it after that, because then the mole of H2PO4 would cancel out with the mole.
So we'd get the moles.
Oh no, that doesn't cancel out. That's right. So this would be 1 mole H2PO4. So the moles would cancel out.
Mm-hmm.
And then we would.
This would cancel as well because this is also right here.
Oh, that's right.
Mm-hmm.
That goes. So now we just gotta. So this is 30 times. Just.
We're looking for atoms, right? So at this point, what do we have?
Oh, how many atoms of phosphorus, not moles.
Right.
So then we just go to atoms. So we've got talk about dyslexia, it's kind of hard for me to go from like,
That's
so that would be, phosphorus, that's,
So we could just throw these numbers right here in front, right? So we do 30 grams over 97, and then
you throw these numbers right now?
right would just do 30 over 97, and that gives us the moles. And so the next thing that we need to do to get from moles to atoms, what conversion factor do we need to have?
From moles to atoms,
Mm-hmm.
the Avogadro's number.
Right. So then we just multiply that by Avogadro's number. All that I did here was just, because we canceled everything out, I just took the numbers and made it into a fraction, because that's all that it is. It's just 30
And that's
divided by
gonna tell us-
97.
And that's going to tell us how many moles there were?
Right. This gives us moles. And so that's what we have right here is just the moles of phosphorus.
How do you know that that gave you moles if we can't, I mean, because we canceled out all of our moles. And all we have, we don't even have any units anymore. All we have is the number 30 and the number 97.
And so if we get this mole didn't cancel, these did. Because remember, this is just a ratio. So the units on this really don't matter. All we are is just comparing the number. And so we could say there's 1 atom of phosphorus for 1 molecule of this.
Okay.
Yeah, does that make sense?
Yeah,
Or
so
1
this one actually
mole.
didn't get canceled out.
Right.
So we just have 30 over 97 moles of phosphorus,
Mm-hmm.
and then we just would multiply that by Avogadro's number.
Perfect.
Okay.
And then we get the atoms.